Picture this. You're standing outside on a clear night, gazing up at the moon, hanging peacefully in the darkness. It's a sight so familiar, so ordinary, that we barely give it a second thought. But here's something that might change how you see that glowing orb forever. According to the mathematics of planetary formation, the moon shouldn't exist, and because it shouldn't exist, neither should we. The probability of Earth having a moon like ours is so astronomically small that statisticians call it a near impossibility. Yet there it hangs, night after night, quietly performing one of the most crucial jobs in the solar system, keeping you alive. Welcome back to this quiet corner of the universe, where we explore the mysteries that surround us every day. I'm so glad you're here, whether you're settling in for the evening or taking a peaceful break from the world. Tonight, we're going on a journey that will fundamentally change how you think about our place in the cosmos. We're going to uncover what might be the most terrifying secret our moon has been hiding in plain sight for over 4 billion years. And I do hope this exploration captivates you just enough to stay curious, but gently enough that if sleep finds you along the way, you'll drift off with wonder rather than worry. After all, sometimes the most profound truths are best absorbed in that quiet space between waking and dreaming. And let's begin with a simple question that has puzzled scientists for generations. Why does Earth have such an enormous moon? I know what you might be thinking. The moon doesn't seem particularly enormous when you look at it. In fact, it appears quite small up there in the night sky, about the size of your thumbnail held at arm's length. But appearances, as they say, can be deceiving. Here's the reality that should make you pause. Our moon is absolutely massive compared to our planet. While Mars has 2 tiny moons that are essentially captured asteroids, and while the giant planets Jupiter and Saturn have dozens of moons that are still proportionally small compared to their host planets, Earth's moon contains 1.2% of our planet's total mass. To put this in perspective, imagine if you weighed 150 pounds and your shadow weighed nearly 2 pounds. That's the relationship we have with our moon. It's not just a satellite, it's almost a companion planet. This massive size ratio is so unusual that some astronomers don't even classify the Earth-Moon system as a planet with a satellite. Instead, they call it a double planet system. We're essentially living on one half of a cosmic dance partnership that shouldn't exist. But here's where things get truly unsettling. The formation of such a large moon requires an event so catastrophically violent and so improbably precise that it defies imagination. 4.5 billion years ago, when our solar system was still a chaotic nursery of forming planets and cosmic debris, something extraordinary happened. Picture the early Earth, a molten world perhaps twice the size it is today, spinning rapidly through space, with days lasting only about 6 hours. Then, travelling at unimaginable speed through the darkness, came an object the size of Mars. Scientists have named this wandering planet Theia, after the Greek goddess who was the mother of the moon. Theia had been growing in the same orbital path as Earth, likely sitting at what we now call a Lagrange point, a gravitational sweet spot, where objects can remain relatively stable. But gravitational stability in the early solar system was a temporary luxury, something perhaps the growing influence of Jupiter or a passing asteroid nudged Theia out of its safe harbour and sent it on a collision course with our world. What happened next was an impact so violent that it makes every natural disaster in human history look like a gentle breeze. When Theia struck the early Earth, it didn't just create a crater or cause an explosion. It fundamentally restructured both worlds at the most basic level. The collision melted Earth's entire crust several kilometers deep. Imagine the entire surface of our planet turning into an ocean of liquid rock, glowing white hot against the black of space. The impact was so energetic that it launched enormous amounts of material into orbit around the devastated Earth, creating a ring of molten debris that glowed like a second sun in the sky. From this ring of destruction, something miraculous happened. Over the course of perhaps just a few hours or days, the debris began to coalesce under its own gravity, forming the moon we see today. It was born from catastrophe, forged in the fires of planetary collision, and it emerged as Earth's unlikely saviour. But here's what should give you pause as you consider this cosmic origin story. The probability of such a collision occurring with exactly the right parameters is so low that it borders on the impossible. Let's talk about probability for a moment, because understanding the odds will help you appreciate just how remarkable our situation truly is. For the moon to form as it did, Theia had to be exactly the right size. Too small, and the impact wouldn't have been energetic enough to launch sufficient material into orbit. Too large, and the collision would have shattered both worlds completely, leaving nothing but asteroids tumbling through space. The impact had to occur at precisely the right angle. A head-on collision would have been catastrophically destructive. A glancing blow wouldn't have transferred enough angular momentum to create our current Earth-Moon system. The angle had to be just steep enough to be dramatic, but shallow enough to be constructive. The speed of impact had to be exactly right. Too fast and both planets would have vaporized. Too slow, and Theia would have simply merged with Earth, leaving us without a moon at all. Even the timing had to be perfect. This collision needed to happen after Earth had grown large enough to survive the impact, but early enough that both worlds were still molten and could reorganize themselves after the catastrophe. When astronomers calculate these probabilities, they arrive at numbers that are almost too small to comprehend. We're talking about odds comparable to throwing a dart from New York and hitting a specific atom in Los Angeles. And yet, here we are, the beneficiaries of this cosmic impossibility. But the formation of the moon was just the beginning of our unlikely story. Once formed, our satellite had to perform a series of equally improbable functions that would prove essential for life's emergence and survival on Earth. Every night when you look up at the moon, you're seeing something that most planetary scientists consider to be the unsung hero of life on Earth. Without it, our world would be a chaotic, uninhabitable hellscape, tumbling through space with no stable seasons, no predictable climate, and no hope of supporting complex life. Here's why. Earth is tilted at about 23 degrees relative to its orbital plane around the Sun. This tilt is what gives us our seasons. When the northern hemisphere is tilted toward the Sun, we experience summer. When it's tilted away, we get winter. This gentle wobble creates the predictable, seasonal cycles that life depends on. But what keeps Earth's tilt so stable? What prevents our planet from tumbling chaotically through space like a cosmic football? The answer is the moon's gravitational influence. Without our lunar companion, Earth's axial tilt would wander dramatically over time. Computer simulations show that our planet's tilt could vary anywhere from nearly 0 degrees to as much as 85 degrees. Imagine winters so extreme that the entire northern hemisphere would be plunged into permanent darkness for months at a time, followed by summers so intense that the polar ice caps would completely melt every year. This isn't speculation. We can see exactly what happens to planets without large stabilizing moons by looking at Mars. The red planet's axial tilt has varied between 10 and 70 degrees over geological time, creating climate swings so extreme that they've left visible geological scars across its surface. When Mars tilts at high angles, its polar regions become the warmest places on the planet. This causes the polar ice caps to sublimate, loading the atmosphere with carbon dioxide and water vapor. The planet becomes warmer and wetter for a time, only to swing back into a deep freeze when the tilt decreases again. Earth, protected by its massive moon, has maintained its gentle 23-degree tilt for billions of years, creating the stable climate that allowed life to emerge, evolve, and eventually contemplate its own existence. But the moon's protective influence extends far beyond climate stability. 4 billion years ago, when life was just beginning to stir in Earth's primordial oceans, our satellite provided another crucial service that may have meant the difference between a living world and a barren rock. The early moon possessed something it lacks today: a powerful magnetic field. This invisible shield, generated by the churning of molten metal in the moon's core, extended far into space and connected with Earth's own magnetic field to create a double barrier against one of the greatest threats facing young planets, the solar wind. Our sun, especially in its youth, was a violent and temperamental star. It regularly unleashed massive solar storms, flares, and streams of charged particles that could strip away a planet's atmosphere in geological short order. We can see evidence of this atmospheric destruction happening right now on Mars, which lost its global magnetic field early in its history and has been slowly bleeding its atmosphere into space ever since. The combination of Earth's magnetic field and the Moon's magnetic field created a formidable defense system. Together, they deflected the worst of the Sun's fury, allowing our planet to retain the thick atmosphere necessary for liquid water and eventually life. This protection lasted for hundreds of millions of years, during the crucial period when Earth's first life forms were establishing themselves and beginning the long journey toward complexity. Without this double magnetic shield, the story of life on Earth might have ended before it truly began. So far, we've explored how the Moon's formation was impossibly unlikely, and how its stabilizing influence and early magnetic protection were essential for life's emergence. But there's something even more unsettling about our relationship with the Moon, something that reveals just how precarious our existence truly is. Because you see, the same forces that created our life-supporting satellite are also slowly taking it away from us. And when I return, we'll discover what happens when Earth loses its ancient guardian, and why the clock is already ticking on one of the most remarkable partnerships in the cosmos. Lid? The story of the Moon's terrifying secret is far from over, and the most sobering revelations are yet to come. As we continue our journey into the Moon's hidden influence on life, there's something both beautiful and unsettling I need to share with you. Every night, as you drift off to sleep, the Moon is quietly, imperceptibly moving away from us. It's a slow dance of celestial mechanics, so gradual that you'd never notice it in a human lifetime. But the Moon retreats from Earth by about 3.8 centimeters each year. That's roughly the same rate at which your fingernails grow. It sounds insignificant, doesn't it? Yet this gentle recession represents one of the most profound countdowns in the history of our planet. You see, as the Moon pulls away, it's gradually weakening its gravitational hold on Earth. And that weakening grip is slowly unraveling the very stability that has protected life for billions of years. Think of it this way. Imagine you're spinning a weight on a string. The faster you spin it, the more the string stretches, but as the string gets longer, the weight moves more slowly, and your control over it diminishes. Eventually, if the string gets long enough, the weight begins to wobble unpredictably. This is precisely what's happening to the Earth-Moon system. As our satellite drifts away, its ability to stabilize our planet's axial tilt is diminishing. In roughly 2 billion years, perhaps less, the Moon will be too distant to maintain its steadying influence. When that happens, Earth's tilt will begin to wander chaotically once again. But here's what makes this timeline particularly sobering. Earth's window for supporting complex life is already narrowing from another direction entirely. While the Moon slowly abandons its post as Earth's stabilizer, our Sun is undergoing its own inexorable transformation. Stars like our Sun gradually brighten as they age, and this brightening is happening faster than you might expect. Over the past 4.5 billion years, the Sun has increased its luminosity by about 30%. That might not sound dramatic, but in cosmic terms, it's enormous. And the brightening continues at a measurable rate, about 1% every 100 million years. This presents what astronomers call the faint young sun paradox. Early in Earth's history, when life was first emerging, our Sun was significantly dimmer than it is today. By all rights, the early Earth should have been a frozen wasteland, with any liquid water locked away as ice. Yet geological evidence clearly shows that liquid oceans existed throughout most of Earth's history. How did our planet stay warm enough for life during those early, dimmer days? The answer lies in a delicate atmospheric balancing act involving greenhouse gases, cloud formation, and yes, the Moon's influence on tidal mixing in the oceans. But this balance is temporary. As the Sun continues to brighten, Earth's climate will eventually become too hot to sustain liquid water, regardless of atmospheric composition. Current models suggest this will happen in roughly 1 billion years, perhaps sooner. So here we are, caught in a cosmic vice. On one side, we have a Moon that's slowly abandoning its protective role. On the other, we have a Sun that's gradually heating our world beyond the limits of habitability. The window of time when Earth can support complex life is surprisingly narrow, and we're living right in the middle of it. To truly understand how precarious our situation is, we need to look no further than our neighbouring planet, Mars. The red planet serves as a haunting preview of what happens when a world loses the protective mechanisms that Earth still enjoys. Mars tells a story of loss that should give us pause. Billions of years ago, the red planet was remarkably similar to early Earth. It had a thick atmosphere, flowing rivers, vast lakes, and possibly even oceans. The geological evidence is undeniable. Ancient river valleys carved into bedrock, sedimentary layers deposited by flowing water, and mineral formations that only occur in the presence of liquid water. But Mars lacked the one thing that has kept Earth habitable, a large stabilizing moon. Without a massive satellite to steady its rotation, Mars has experienced wild swings in its axial tilt over geological time. When the planet tilted at extreme angles, its climate became chaotic and unstable. The polar ice caps would melt, loading the atmosphere with water vapor and carbon dioxide. Then, as the tilt changed again, the planet would plunge into deep freezes that lasted for millions of years. These climate oscillations, combined with Mars' smaller size and weaker magnetic field, gradually stripped away the planet's atmosphere. The solar wind, no longer held at bay by a global magnetic field, slowly but relentlessly carried away the gases that had once made Mars a potentially habitable world. Today, Mars has an atmosphere less than 1% as thick as Earth's. Its surface pressure is so low that liquid water cannot exist except under very specific conditions. The planet that once might have harboured life has become a cold, dry desert where the average temperature is -80 degrees Fahrenheit. This is what awaits any planet that loses its protective mechanisms. And it's a future that Earth will eventually face as the Moon continues its slow retreat. But the Moon's influence on Earth extends beyond climate stability and magnetic protection. There's another crucial role our satellite plays, one that may have been essential for life's very origins: the creation of tides. When you watch waves gently lapping at a beach, you're witnessing one of the most important processes in the history of life on Earth. These tides, driven primarily by the Moon's gravitational pull, create something that scientists believe was crucial for the emergence of complex chemistry. Tidal pools. Picture the early Earth, with its primitive oceans lapping against barren coastlines. Twice each day, the Moon's gravity would draw these waters up onto the land, creating shallow pools filled with seawater. As the tide receded, these pools would be left behind, slowly evaporating under the alien sky. This process of filling and emptying, wetting and drying created perfect conditions for concentrating organic molecules. In these tidal pools, the building blocks of life could accumulate, interact, and begin the chemical dance that would eventually lead to the first self-replicating molecules. But here's what makes this even more remarkable. The early Moon was much closer to Earth than it is today. When life was first emerging, our satellite was perhaps only 15,000 miles away, compared to its current distance of about 240,000 miles. This proximity created tides that were absolutely massive, potentially hundreds of feet high. These super tides would have swept far inland, creating vast networks of tidal pools across the early continents. The constant mixing and concentrating of organic molecules in these pools may have provided exactly the right conditions for life's chemistry to bootstrap itself into existence. As the Moon has receded over billions of years, these extreme tides have gentled into the familiar rhythms we know today. But those ancient super tides may have been the midwife that helped deliver life into our universe. All of this brings us to one of the most sobering realizations in modern astronomy. The conditions that allowed complex life to emerge on Earth may be so specific, so unlikely, that we might be alone in the universe. This idea, known as the rare Earth hypothesis, suggests that while simple microbial life might be common throughout the cosmos, the development of complex multicellular organisms requires such a precise combination of factors that it may be extraordinarily rare. Consider the list of requirements we've discovered just in our exploration of the Moon's role. A planet needs to form in the right location, around the right type of star. It needs to be the right size to maintain geological activity. It needs to have the right atmospheric composition, and it needs to experience exactly the right kind of catastrophic impact to create a large, stabilizing moon. But that's just the beginning. The planet also needs to be protected by a massive outer planet like Jupiter, which acts as a cosmic vacuum cleaner, sweeping up asteroids and comets that might otherwise pummel the inner solar system. It needs to maintain liquid water for billions of years while its star gradually brightens. It needs to avoid being tidally locked, which would create a world of permanent day and night. When astronomers try to calculate the probability of all these factors occurring together, they arrive at numbers so small they're almost meaningless. We're talking about odds of perhaps 1 in a trillion, or even less likely than that. Yet here we are, the apparent beneficiaries of this cosmic lottery, living on a world that by all rights shouldn't exist, orbited by a moon that should never have formed, in a solar system arranged with impossible precision. As we contemplate these vast scales of time and probability, it's natural to wonder what the future holds for our unlikely partnership with the moon. The story we've been telling has been one of gradual loss, of protective mechanisms slowly failing as cosmic forces pull our guardian satellite ever further away. In about 600 million years, the moon will be far enough away that total solar eclipses will no longer be possible. That perfect alignment that allows our satellite to exactly cover the sun's disk, revealing the corona in all its ethereal beauty, will become a thing of the past. Future inhabitants of Earth, if any exist, will only know eclipses from historical records and ancient photographs. But long before that aesthetic loss, more fundamental changes will reshape our world. As the moon's stabilizing influence weakens, Earth's climate will begin to fluctuate more dramatically. The ice ages that have periodically gripped our planets will become more severe and less predictable. The seasonal patterns that life has adapted to over millions of years will start to shift and wander. Eventually, perhaps in 1 billion years, the combination of a distant moon and a brightening sun will make Earth uninhabitable for complex life. The oceans will boil away, the atmosphere will be stripped by solar wind, and our planet will join Mars in the catalogue of worlds that once harboured life but could no longer sustain it. This might seem like a depressing conclusion to our exploration, but I'd like to suggest a different perspective. We are living in the most remarkable moment in cosmic history. We exist during the brief window when a planet and its moon have achieved perfect balance, creating conditions stable enough for consciousness to emerge and contemplate its own existence. We are the universe becoming aware of itself. If only for a cosmic instant, we are stardust that has organized itself into patterns complex enough to wonder at the stars. We are matter that has learned to question matter, space that has developed the capacity to explore space, time that has gained the ability to measure time. As our journey through the moon's terrifying secret draws toward a close, I find myself returning to that image we began with. You standing outside on a clear night, looking up at our satellite, hanging peacefully in the darkness. But now you see it differently, don't you? That familiar orb is no longer just a pretty light in the sky. It's a cosmic miracle, born from catastrophe, shaped by impossibility, and serving as the silent guardian of everything you've ever known or loved. Every breath you take, every sunset you witness, every changing season you experience, exists because of an astronomical accident so unlikely that it challenges our understanding of probability itself. You are here because two worlds collided with perfect precision 4.5 billion years ago, creating a partnership that has protected life through countless cosmic dangers. The moon has been humanity's constant companion throughout our entire existence. It has watched over the first stirrings of life in ancient oceans, witnessed the rise and fall of countless species, and now illuminates the nights of a civilization capable of understanding its own cosmic significance. When early humans first looked up at the moon and wondered what it was, they could never have imagined the profound role it plays in their very existence. When ancient astronomers first calculated its distance and size, they had no idea they were measuring the dimensions of their own life support system. Now, as we stand on the threshold of becoming a spacefaring species, we're beginning to appreciate just how rare and precious our Earth-Moon system truly is. In all our searching for exoplanets and signs of life elsewhere in the universe, we have yet to find another world with a moon quite like ours. This rarity should fill us with both humility and wonder. Humility, because it reminds us how improbable our existence is, how many cosmic coincidences had to align perfectly for consciousness to emerge in this corner of the universe, and wonder, because it reveals that we are living through one of the most extraordinary chapters in the story of the cosmos. So tonight, when you step outside and see the moon hanging in its familiar place, remember that you're looking at more than just a satellite. You're seeing the architect of seasons, the guardian of climate, the protector of atmosphere, and the midwife of life itself. You're witnessing a cosmic partnership so rare that it may be unique in our galaxy, perhaps in the entire universe. You're observing the slow dance of two worlds whose gravitational embrace has made possible everything from the first organic molecules to the thoughts you're thinking right now. The moon's terrifying secret isn't really terrifying at all. It's magnificent. It's the secret that life on Earth exists against all odds, sustained by forces so vast and precise that they humble our greatest achievements and inspire our deepest sense of cosmic connection. And perhaps most beautifully, it's a secret that we finally learned to read, written in the language of orbital mechanics and gravitational physics, told through the patient observations of generations of scientists who dared to look up and ask, how did this impossible thing come to be? We are here, against all probability, under the protection of our ancient guardian, living in the most remarkable moment cosmic history has yet produced. And that, I think, is worth contemplating as you drift off to sleep tonight, safe under the watchful eye of the moon that shouldn't exist, on the planet that shouldn't be here, in the universe that somehow conspired to make both possible. Sweet dreams, fellow travellers. The cosmos has been very, very good to us. If this exploration of our cosmic improbability has stirred your sense of wonder, you might enjoy discovering another unsettling truth about our place in the universe. In our next journey together, we'll uncover why the speed of light might not be what it seems, and how this revelation could fundamentally change everything we think we know about reality itself. Until then, keep looking up, keep wondering, and remember how extraordinarily fortunate we are to be here at all. But there's another layer to this cosmic puzzle that we haven't fully explored yet, one that might be the most unsettling piece of all. It's not just that the moon exists or that it performs these crucial life-supporting functions. It's when all of this happened that should truly take your breath away. You see, the timing of the moon's formation represents what might be the most extraordinary coincidence in the history of our solar system. The Theia impact occurred approximately 4.5 billion years ago, just 50 million years after the formation of Earth itself. In geological terms, that's practically instantaneous. It's like waiting 4.5 hours for something to happen, and then having it occur in the final 2 minutes. Why does this timing matter so profoundly? Because it created what scientists call the Goldilocks window for life's emergence. Too early, and Earth wouldn't have been large enough or stable enough to survive such a catastrophic impact. Too late, and our planet's crust would have already solidified, making the kind of global restructuring necessary for life's chemistry impossible. The impact needed to happen after Earth had accumulated enough mass to retain a substantial atmosphere, but before the planet had cooled enough to lose its geological flexibility. The window for this perfect timing was perhaps only a few tens of millions of years out of the billions of years in our solar system's history. Think about that for a moment. In the vast sweep of cosmic time, there was only the briefest opportunity for this world-shaping collision to occur, with beneficial results, earlier or later, and we would be living on a very different planet if we were living at all. The Theia impact didn't just create the moon and stabilize Earth's rotation, it fundamentally altered the chemistry of our world in ways that may have been essential for life's emergence. When Theia struck the early Earth, the collision didn't simply melt the surface, it created a global magma ocean that persisted for millions of years. This molten state allowed heavy elements to settle toward the core, while lighter materials rose to form the crust. More importantly, it created the perfect conditions for what geochemists call late veneer processes. During this period of global melting, volatile compounds that had been locked away in Earth's interior were released into the atmosphere and oceans. Water vapor, carbon dioxide, methane, ammonia, and countless other organic compounds filled the air and dissolved into the seas. It was a primordial soup rich in the building blocks of life. But here's what makes this particularly remarkable. The exact composition of this early atmosphere appears to have been perfectly tuned for the emergence of complex organic chemistry. Too much oxygen, and organic molecules would have been destroyed by oxidation. Too little carbon dioxide, and the greenhouse effect wouldn't have been strong enough to keep the oceans liquid under the dim young sun. The chemical signature left by the Theia impact created what researchers call a reducing atmosphere, one that favoured the formation of organic compounds rather than their destruction. This atmospheric composition persisted for hundreds of millions of years, providing exactly the right conditions for life's chemical precursors to accumulate and interact. Modern experiments have shown that when you recreate these early atmospheric conditions in the laboratory, organic molecules form spontaneously from simple starting materials. It's as if the moon's violent birth deliberately prepared Earth to be a nursery for life. Earlier, we touched on the moon's ancient magnetic field, but there's something even more intriguing about this protective shield that we need to explore. The moon's magnetism wasn't just strong, it was synchronized with Earth's magnetic field in a way that created what planetary scientists call a magnetospheric coupling. Imagine two soap bubbles touching each other, their surfaces merging to create a larger protective envelope. This is essentially what happened with the early Earth-Moon magnetic system. The two fields joined together, creating an extended zone of protection that was far more effective than either field could have been alone. This coupled magnetic field persisted for hundreds of millions of years, from approximately 4.1 to 3.5 billion years ago. During this crucial period, life was taking its first tentative steps in Earth's oceans. The timing, once again, appears to be more than coincidental. What makes this magnetic coupling even more remarkable is that it required both worlds to have active, molten cores generating strong magnetic fields simultaneously. For Earth, this makes sense. Our planet is large enough to maintain geological activity for billions of years. But the Moon, being much smaller, should have cooled and solidified relatively quickly. Yet somehow, the Moon maintained its magnetic field for precisely the length of time needed to protect Earth's early biosphere. As soon as complex life forms had established themselves and Earth's own magnetic field had stabilized, the Moon's magnetism quietly faded away, as if its job was done. There's another aspect of the Earth-Moon system that reveals just how precisely tuned our cosmic partnership really is. It has to do with something called orbital resonance, and it's a phenomenon so delicate that even tiny changes could have catastrophic consequences. When the Moon first formed, it was much closer to Earth than it is today. Some estimates suggest it may have been only 15,000 miles away, compared to the current distance of about 240,000 miles. At this proximity, the gravitational forces between the two worlds were enormous. The moon's gravity didn't just create tides in Earth's oceans, it also created tides in the solid rock of our planet's crust. These Earth tides caused our world to flex and bulge as the moon passed overhead, generating tremendous internal friction and heat. This tidal heating served several crucial functions. It kept Earth's interior molten for longer than would have been possible through radioactive decay alone, ensuring that our planet maintained the geological activity necessary for a stable climate. It also drove the formation of Earth's early magnetic field by stirring the molten iron in our planet's core. But perhaps most importantly, this tidal interaction began the slow process of pushing the moon away from Earth while gradually slowing our planet's rotation. This created what astronomers call a resonant evolution, where both worlds changed together in a synchronized dance. The beauty of this system is that it's self-regulating. As the moon moves away, the tidal forces weaken, but they weaken at exactly the right rate to maintain stability. If the moon had receded too quickly, Earth would have lost its stabilizing influence too soon. If it had moved away too slowly, the tidal forces would have remained so strong that they might have torn both worlds apart. Instead, we have a system that has maintained perfect balance for billions of years, gradually evolving in a way that has consistently favoured the emergence and persistence of complex life. About 3.9 billion years ago, just as life was beginning to establish itself in Earth's oceans, our solar system experienced one final catastrophic event that could have ended the story of terrestrial life before it truly began. Astronomers call this period the Late Heavy Bombardment, and it represents perhaps the most dangerous chapter in our planet's early history. During this time, which lasted for about 200 million years, the inner solar system was pelted by an unprecedented barrage of asteroids and comets. These weren't small pebbles. Many were massive objects, capable of creating craters hundreds of miles across and sterilizing entire continents. The cause of this cosmic storm is still debated, but most scientists believe it was triggered by a massive reorganization of the outer planets. As Jupiter and Saturn settled into their current orbits, their gravitational influence scattered millions of asteroids and comets throughout the solar system, sending many of them careening toward the inner planets. Earth bore the brunt of this bombardment. Impact craters from this period, now largely erased by geological processes, would have covered our planet's surface. Each major impact would have vaporized vast quantities of seawater, temporarily sterilizing large portions of the biosphere. But here's where the moon's protective influence becomes crucial once again. Our satellite, with its heavily cratered surface, bears permanent scars from the late heavy bombardment. Many of those craters represent impacts that might otherwise have struck Earth. The moon served as a cosmic shield, absorbing countless projectiles that could have made our planet uninhabitable. Without this protection, Earth might have been so thoroughly sterilized during the bombardment that life would never have had a chance to recover and evolve into the complex forms we see today. One of the most beautiful and haunting aspects of the Earth-Moon system is how it has functioned as a cosmic timekeeper throughout the history of life on our planet. The rhythm of the tides driven by our satellite's gravitational pull has been a constant presence in the story of terrestrial evolution. But this tidal clock has been gradually winding down as the moon retreats from Earth. Early in our planet's history, when the moon was closer, days were much shorter and tides were much higher. Fossil evidence from ancient coral reefs shows that 400 million years ago, there were about 400 days in a year, each lasting roughly 22 hours. This means that as life evolved, it had to constantly adapt to changing tidal rhythms. The creatures that survived were those flexible enough to adjust to gradually lengthening days and slowly diminishing tides. This constant, gentle pressure for adaptation may have been one of the driving forces behind the evolutionary complexity we see in life today. Many organisms still carry the memory of these ancient tidal rhythms in their biology. Certain marine animals have internal clocks that match the moon's phases, even when they're kept in laboratories with no access to natural light or tidal information. These biological rhythms, known as circulunar cycles, are living fossils of our planet's tidal history. As the moon continues to recede, these ancient rhythms are slowly fading from the biological record. In a sense, life on Earth is gradually losing touch with the cosmic forces that shaped its evolution. We are living witnesses to the slow dissolution of a partnership that has lasted for billions of years. All of this has profound implications for our understanding of life elsewhere in the universe. As we search for potentially habitable exoplanets, we're learning that simply being in the habitable zone around a star isn't enough. A world needs the right size, the right atmosphere, the right magnetic field, and as we now understand, the right kind of moon. Large moons like ours appear to be exceedingly rare. Most of the exoplanets we've discovered either have no moons at all or only tiny satellites that couldn't provide the stabilizing influence that complex life requires. This suggests that Earth-like worlds capable of supporting complex ecosystems may be far rarer than we once imagined. The formation of a large moon requires such specific conditions that many astrobiologists now consider it to be one of the key filters that determine whether a planet can develop and sustain complex life. It's not enough for a world to have liquid water. It also needs the cosmic accident of a perfectly timed giant impact to create a large satellite. This realization is both humbling and inspiring. It suggests that we may indeed be alone in our galaxy, perhaps even in the observable universe, as far as complex life is concerned. But it also means that we are living through something truly extraordinary. The brief cosmic moment when matter has organized itself into patterns complex enough to understand its own origins. As we near the end of our exploration, it's worth reflecting on what all of this means for our understanding of existence itself. The story of the moon reveals that we are the beneficiaries of what might be the most improbable sequence of events in cosmic history. Every aspect of our existence, from the stability of our climate to the chemistry of our cells, depends on a series of astronomical coincidences that defy rational probability. We are here not because the universe was designed for life, but because we happen to exist during the brief window when an impossible set of circumstances has aligned perfectly. This perspective can be either deeply unsettling or profoundly liberating, depending on how you choose to view it. On one hand, it suggests that our existence is far more fragile and temporary than we might like to believe. We are cosmic butterflies, beautiful but ephemeral, existing only because of a series of accidents that will never be repeated. On the other hand, it means that every moment of consciousness, every experience of beauty, every act of love and creation represents something genuinely precious in cosmic terms. We are not just another species on another planet. We are the universe's attempt to understand itself, occurring at the only time and place where such understanding appears to be possible. The moon hanging in our night sky is more than just a satellite. It's a reminder of how special this moment in cosmic history truly is. It's a symbol of the extraordinary chain of events that brought us into existence and continues to sustain us against all odds, and so we arrive at the ultimate paradox of our existence. We shouldn't be here, yet here we are. The moon shouldn't exist, yet it circles faithfully overhead, night after night. Life shouldn't have emerged on Earth, yet it has flourished into forms of staggering complexity and beauty. Perhaps this is the most profound lesson the moon has to teach us: that impossibility and reality are not mutually exclusive, that the most meaningful aspects of existence often arise from the least likely circumstances, that in a universe governed by probability and chance, the most improbable outcomes can sometimes be the most significant. When you look up at the moon tonight, you're seeing proof that the impossible is possible. You're witnessing evidence that even in a cosmos ruled by mathematical laws and physical constraints, there's still room for magic, mystery, and wonder. The moon's terrifying secret isn't really terrifying at all, it's miraculous. It's the secret that we exist at all, against odds so astronomical that they challenge our understanding of possibility itself. It's the secret that consciousness has emerged in this corner of the universe, if only for a brief cosmic moment, to contemplate its own extraordinary origins. And perhaps most beautifully, it's a secret that reminds us how precious and fleeting our moment in the cosmos truly is. We are stardust that has learned to wonder at the stars, matter that has developed the capacity to ponder matter, time that has gained the ability to measure itself. We are here under the light of an impossible moon, on a planet that shouldn't exist, in a universe that somehow conspired to make it all possible. And that, I think, is worth celebrating as you drift off to sleep tonight, safe in the knowledge that the cosmos has been extraordinarily kind to us all. If this journey through cosmic improbability has left you curious about other hidden mysteries of our universe, you might be intrigued by something even more fundamental to our existence. Next time, we'll explore a question that will change how you think about reality itself. What if time isn't real? What if everything you've ever experienced, every memory you cherish, every moment you've lived, exists simultaneously in what physicists call the block universe? It's a concept so mind-bending that it challenges the very foundation of human experience, and it's waiting for us in our next quiet exploration together. Until then, keep wondering, keep looking up, and remember how remarkably fortunate we are to be conscious observers in this brief window of cosmic possibility. Sweet dreams, fellow travellers, through space and time. As we settle deeper into this cosmic story, there's something profoundly melancholic I need to share with you. The moon that has been humanity's faithful companion for all of recorded history, the same moon that inspired our earliest myths and guided our first navigators, is slowly but inexorably abandoning us. This isn't a sudden departure, mind you. It's happening so gradually that 1,000 human lifetimes wouldn't be enough to notice the change with the naked eye. But when you understand the mathematics of orbital mechanics, the reality becomes inescapable. Every night that passes, every tide that rises and falls, every moment of Earth's rotation is part of an ancient countdown that began the instant our satellite formed. The mechanism is elegantly simple, yet its consequences are profound. As Earth spins on its axis, it drags the tidal bulge created by the moon's gravity slightly ahead of our satellite's position. This creates a gravitational torque that gradually transfers energy from Earth's rotation to the moon's orbit, causing our planet to spin more slowly while pushing the moon farther away. It's a process that has been happening for over 4 billion years, and it will continue until one of two things occurs. Either the sun expands into a red giant and engulfs both worlds, or Earth and Moon become tidally locked. with each world showing only one face to the other, like dancers frozen in an eternal embrace. Current calculations suggest the first scenario is more likely. We have perhaps another billion years before the sun's increasing luminosity makes Earth uninhabitable, but the moon will continue its retreat throughout that entire period, gradually weakening its protective influence on our world. Imagine, if you will, what the night sky looked like to the first creatures that crawled from Earth's primordial seas onto dry land. The moon they saw was dramatically different from the one that illuminates our evenings today. 400 million years ago, when the first plants were colonizing the continents and early fish were developing limbs, the moon appeared roughly twice as large in the sky as it does now. It was a magnificent, looming presence that would have dominated the heavens with an almost supernatural intensity. The tides created by this closer moon were extraordinary. Where we see gentle waves lapping at beaches, early Earth experienced tidal ranges that could exceed 300 feet. Entire coastal plains would flood twice daily, creating vast tidal zones that stretched for hundreds of miles inland. These massive tides had profound effects on evolution itself. The creatures that survived in this dynamic environment had to be incredibly adaptable, able to thrive in conditions that alternated between marine and terrestrial with clockwork regularity. This constant challenge may have been one of the driving forces that pushed life toward ever greater complexity. The day itself was dramatically different. With the moon closer and Earth spinning faster, a full day-night cycle lasted only about 22 hours. There were roughly 400 days in each year, creating a world where seasonal patterns unfolded more quickly than they do today. Plants had to adapt to this accelerated rhythm, developing internal clocks that could track the rapid succession of days and nights. Animals evolved migration patterns timed to these shorter years. The entire biosphere marched to the beat of a cosmic drummer that was gradually, imperceptibly slowing down. One of the most poignant ways we can trace the moon's retreat is through the fossil record itself. Ancient corals, growing in the shallow seas of hundreds of millions of years ago, recorded the rhythm of days and tides in their growth patterns, creating what paleontologists call natural calendars, preserved in stone. These coral fossils show distinct daily growth lines, much like the rings in a tree trunk, but they also show monthly patterns corresponding to the lunar cycle and annual patterns marking the changing seasons. By counting these microscopic lines, scientists can determine exactly how many days existed in ancient years. The evidence is unmistakable. 400 million years ago, there were about 400 days per year. 500 million years ago, there were closer to 410. The mathematical progression is perfect, matching theoretical predictions about how tidal friction should slow Earth's rotation over geological time. But these fossil timepieces record more than just the length of ancient days. They also preserve evidence of the moon's gravitational influence on early life forms. Many of the growth patterns show clear correlations with lunar cycles, suggesting that even primitive organisms were already synchronizing their biological rhythms with our satellite's phases. In essence, these fossils are love letters from the past, written in calcium carbonate and preserved in sedimentary rock. They tell us that the relationship between Earth and Moon has been intimate and ongoing for billions of years, shaping not just our planet's physical evolution, but the very rhythm of life itself. Tonight, as you prepare for sleep under the gentle glow of our impossible moon, remember this. You are witnessing one of the most extraordinary partnerships in cosmic history, a dance between two worlds that has sustained life against odds so astronomical they defy comprehension. The moon's terrifying secret isn't that it threatens our existence, but that our very existence depends on a series of cosmic accidents, so improbable they challenge everything we thought we knew about how rare and precious consciousness truly is. We are stardust that learned to wonder, living in the brief shining moment when the universe opened its eyes to see itself. Sweet dreams, fellow travellers through this miraculous cosmos.